Hi there, welcome back to the channel and welcome to the next video in the restoration series of the SABA Stereo I. In this video I'm going to do the AM section alignment, testing and alignment. We find a few problems, we solve them, we do the alignment, we do some visual checking. I do the alignment by the book. They've got very good instructions in the service manual. In fact, this particular one has got German and English, which makes life a lot easier. I also decided to give it a check at the end. We're using a visual method, a sweep method, just to check what the by the book alignment results in. And it's a nice surprise. You'll see for yourself, but it's a nice surprise. The other thing is I wanted to test this little thing. This is one of those cheap frequency counters. And I wanted to check some frequencies on here. And obviously with the dial the way it is, you can't do that. So I decided to put this thing into action and see if it's anywhere near accurate. And again, I was astounded. I was looking for a particular BBC transmission frequency and I found it spot on, give or take half a kilohertz. I didn't expect that, but this is what you get. This particular SABA, we'll also talk about this, but I noticed it's not quite to the standard of some of those real machines they made previous to this, like the Freiburg, the Meersburg. The Freiburg 9, the Freiburg 125, those things are incredibly complex, incredibly luxurious radios. And they had, 3 IFs and they had all sorts of stuff. We noticed when working on this one, it's a very good receiver. No, don't get me wrong, but it's got 2 IFs and the tuning, the alignment instructions are different and show you how some corners may sort of have had to be cut because those things must have been extremely expensive to build. So anyways, if you enjoy this sort of thing, stick around and enjoy the video. Before we carry on, I just want to thank the sponsors of the video. PCBWay, you'll find them at PCBWay.com. This is the company that produces all the PC boards that I use on my channel. They have an incredible amount of services and capabilities. And what I want to call your attention to today is actually their shared projects section. Here you'll find a huge range of projects that other creators have uploaded and shared with you. And if this is what you're looking for, you can go here and order directly from the link, order your PCBs and recreate the project. Obviously in this case, the creator has got a video on precisely what he's done and help you to build your own. Whether you need project ideas or PC boards or assembly, 3D printing, pop over to PCBWay. I'm sure you'll find something for you right there. You might recognize a few things as being different since the last time I showed you this, and mainly what I've done, in fact all I've done, is I've replaced that dial cord. If you remember, that dial cord was a little bit weird. There was a piece that had been added on at the end there and it was messing it up, and it wasn't getting to the end because there was a knot on there that just got caught on that pulley. So now that's all working perfectly. There's no mystery here. There's actually a very good drawing for this. But I didn't even have to refer to the drawing because I just followed the old string, just replaced the old string with the new one. And it's working very well. I put those markers on there because those are the extents of the dial. I just wanted an indication. But I got a problem because I don't get anything on medium wave, which is a bit strange. I've got the mini whip at the back and I'll show you shortwave first. Give it a bit of time to warm up. There might be nothing on at the moment because it's early afternoon, but it's making the right noises and those noises can get really loud. So it seems to be doing the right thing. We'll check later tonight and see what happens. Now, if I put on medium wave, I'm getting bugger all. There's a patch here that sort of picks up a bit, then goes down again, long wave. Something there, very faint. Okay, I've got something there, long wave, which is a bit odd. But then I realized the ferrite antenna is the one that's being used here. So if I want the external antenna, I've got to turn it all the way across, till it clicks in place there. Okay, so let's see what we get on medium wave. Absolutely nothing there. A little bit over here. It seems to be completely dead. Shortwave's making the same noises. Long wave.
Le royaume et la République gabonaise. L'ONU lance.
There's one station there. I think it's from Morocco. So, something wrong with mini wave and long wave. Now, because shortwave is working, or seems to be making the right noises, I think the whole IF chain is fine. I'm going to check that tube, the ECH81. I'm going to replace it with another one, this one here. It's a new old stock, so I know that's working. And I'll get right back to you. Well, that wasn't good news because I've got exactly the same thing. I've got a bit of a noisy patch there. And it's about exactly the same. Now, I've got one other tube in there, and that is the EAF801, and that is the pentode and diode detector. Now, I don't have a replacement for that, so I'm really praying that's not a problem. You can sort of replace that with the EBF89, which I do have spares for, but it's not exact. The EBF89 has got another diode, and it also has a different shielding structure. So I don't really know what's wrong with this. Actually, I've just had an idea. Let me try something. Okay, listen to this. Ha. See that? Nothing wrong with the tubes. I'll tell you what was wrong. The antenna switch was wrong. The antenna switch is dirty. Let me show you what I mean. See, what I did here is I actually just put a jumper across those two contacts of that switch, that one and that one. And those are those two over there. These guys get clicked in. See, when you get the ferrite antenna rotated all the way to the one side, it disconnects from the ferrite to the external antenna. And this switch here was not making good contact. This one. There's obviously dirt in there, and what I did is I just shorted these two out with the clip, and it starts working. It's probably cleaned itself now, but see that? It's just it's that contact. So I've got to clean that, and I think we'll have solved this problem. So I've got to clean that contact there.
Saludos, criaturas. Soy un gran defensor de todo lo americano, pero en oftalmología solo confío en producto nacional. Para operarme hoy pide cita en el 900-180-100 o en clinicabaviera.com y corrige la vista cansada.
Celebramos el gran final del 30 aniversario.
This one here might be the long wave, I'm not sure. Now reactivate it. Beautiful.
Te voy a resumir esto rápido. Más móvil, fibra y dos líneas móviles con 30 gigas a compartir. Y todo esto por 39,90 euros al mes.
I'm happy with that. Let's try these again.
99.1 en FM y en onda.
El objetivo no es otro, ¿verdad? Y van los sellos de correo. Buenas tardes.
That's what I expect early afternoon on medium wave with the mini whip.
Si es un soldado. Es saber.
What's happening here? Still not perfectly clean, but I'll do that again. Let's try long wave. Well, it seems that the dirty contacts only apply to medium wave over there. So it looks like that's all working. Short wave I'll try tonight. Not getting anything at the moment. So, long wave, medium wave, working. Okay, good. What do I have to do here? Well, this is the thing with this radio. Because a lot of those capacitors are more modern than the paper caps, there really is very little to do in there. There are no capacitors that need changing. So that's good news. If they did need changing, they're actually quite easy with this board. I'm happy with this PC board. I'm actually very happy with it. So what I'm going to do again is I'm going to give it another round of cleaning of the contacts of the switches. And of course the antenna switch over there as well. Now that's the thing with these SABAs. All these little switches are really great and they give this thing a lot of functionality, but they do have the problem that they do tarnish, and that's when you start getting faults that can drive you crazy. Now, why did I remember that? Because on the first SABA I did, I'm almost embarrassed to say this. It took me about 2 days of trying to fault find before I realized that this thing had a switch at the end. I just hadn't worked on it before. I hadn't thought about it. On the dial itself, there's actually a symbol that shows you that at the end of that rotation, you should, you get the external antenna. I didn't read that. I didn't see that. So that's why I jumped to that quite quickly. But it could have taken quite a long time to figure this out. You can go through the whole schematic and check all the continuity on the coils. And of course, the same applies to the continuity of the switches. Learned my lesson recently with that little Blaupunkt. If I'd gone and cleaned the switches straight away, I would have had the problem sorted right at the beginning. But you sort of pick up these little things. You start realizing that things do repeat themselves. A problem that you find now and you discover how to resolve, it's normally something that you put into your arsenal, and the next time round it becomes a lot easier. It's not so much being smart, it's just experience does help. It does help a lot. So AM is working. I'm going to go through the alignment procedure more for the opportunity to be able to show you how it's done than for improving the reception, because I think this thing is actually receiving very well. I don't think anybody's messed with this, but it's got a very interesting alignment procedure which I think might be beneficial if you ever come across one of these. So that's what I'm going to be looking at next. I've done a little bit of actual cleaning of the PC board with the compressor that I've got using alcohol, and it cleaned up very, very well. Very, very easy. I just put it on its side, used the airbrush and a little bit of the manual brush, and it all just came out. That board is clean. That's the audio board. So I need to do the same on this side. On this side, remember, there are a lot of little wires on there from the coil, so you've got to be a little bit more careful, but I'll be doing that as well. So we have another part of the device completely cleaned up. It's looking good. It's looking good, and it's actually been quite cooperative so far. Let's hope it continues that way. The first stage of the alignment procedure is going to be the IF alignment for the AM bands. And this radio has got two IF transformers, one here, one here. The difference between this one and the normal radios is that these transformers are a lot more detailed and a lot higher quality than what we're used to. The detail that goes into these is amazing, and I've actually spoken about this, I think, on the Breisgau 8. I think I opened one of them, not quite sure. But here we've got a typical IF transformer. It's got the two coils for the AM and the two coils for the FM. Same here. The one thing that's different about these is that it's got a coupling adjustment. So besides adjusting the one coil and the other, so they resonate at the IF frequency, you can then adjust the amount of coupling between them. And if I'm not mistaken, this changes the spread, or the, let's call it the bandwidth that you'll be able to achieve from them. We're going to look at the service manual, see exactly what they tell us to do. I'm going to follow the service manual pretty closely because I found that with the SABAs, that's really what you want. There's one other detail on these alignments that is slightly different to the others. You can do it with the others, but these actually come in the instructions. And that is, they tell you to feed a negative voltage to a particular pin of this breakout socket. And the reason is you want to feed a negative voltage to annul or to cancel the effect of the AGC, the automatic gain control. So this is not as sensitive to the amplitude of the signal that you use as some of the other radios are. I've said this multiple times, and so has everybody else, that when you do an alignment, you've got to align it with the lowest amplitude that you can discern, that you can hear, because you don't want your automatic gain control to kick in and mess up your alignment. They tell you to feed pin 3 over here, which is P on the schematic, 1, 2, 3, a minus 4.5 volts signal or voltage, and that's why I've got this little extension sorted out. I'm going to feed this with the voltage from the power supply. You can use a battery as well. They tell you to use the battery, but I use the power supply. And they tell you to feed this voltage or supply this voltage between pin P and Y. Now I know that Y is pin 1 and it's also the chassis. So I'm just going to connect the power supply to the chassis and connect the other pin to this point over here. Now it's minus 4.5 volts. So you've got to connect the positive lead of the power supply to the chassis and the negative to this point over here. Don't get that wrong. And here is our supply. So negative will go to the chassis. I'll just connect that to here. You see, I was getting it wrong again. It's minus 4.5. So negative goes to there. And the positive goes to here. Now remember, this must be a floating voltage. This cannot be from a supply that's connected to earth. Okay, now my bench supply is isolated, and the reason for that is you don't want to short your grounds. If your supply is connected to earth, the signal generator, which I'm using as well, is connected to earth, so you'd have a ground short. So we are ready now, except for the actual signal connections. What we have here is the signal coming in, feeding in, and I've actually soldered this cable to ground and to the pin 2, which is the grid 1 of the ECH81 as per the instructions, and we'll see that in a minute. And the signal doesn't come directly from the signal generator. It comes from the signal generator. I've got 460 kilohertz, the lowest amplitude that my signal generator will produce. It's coming out of here and it's going to that switched attenuator where I can add all these attenuation steps and make it as weak or as strong as I want to. At the moment, I've got it pretty much attenuated. I think I've got, 12 plus 6 plus 3, so 18, 21 dBs of attenuation. We'll see if we need that much attenuation or not. This thing is got a capacitor in here, so it's already not direct coupled, which is something that you need to be careful with. They tell you to not couple it directly. So we don't need to put a capacitor because we've got one in there. I've got modulation on, 30% AM modulation. And the tone, what tone did I choose? 1 kilohertz. Okay, so we can feed that as well. And then I've got my speakers going to here, to the dummy load switcher. And I'm going to be monitoring on the scope. I don't need to, because I'll be measuring. I've got this signal coming out here, going to the AC millivolt meter, which is over here. And on this AC meter, I'm going to be measuring the amplitude of the audio tone at the speakers, which is the output that they want you to measure, and use that to adjust the chords. So let's look at the service instructions and get started. We're fortunate in that this model has the full alignment instructions. Here you've got the instructions in German, but then we've got the instruction in English, and that's what we're looking at here. And the first thing they tell us is to cut the AVC by applying the 4.5 volts from a low resistance battery to test point R, which is the negative connection, and Y, which is the positive connection. And we know that these are the AGC feed-off point, which you're going to annul, and Y is the chassis. Connect the output meter to the output, which we've done, and turn the treble control to left stop. So we are turning the treble to minimum. Okay, done all that. Then to do the 460 kilohertz alignment, press medium wave, which we've done, and connect the signal generator with 30% amplitude modulation through a 0.01 microfarad capacitor to the control grid of the mixer tube ECH81, which is what I've done. And the coupling of the IF transformers is decreased, subcritical, by turning the screw counterclockwise, increase. That just tells us that on here, counterclockwise is decreasing and clockwise is increasing. Okay, Now we're going to focus on IF transformer 4, and the coils we are looking at are L384 and L385, and the critical or subcritical, the coupling adjustment is K384, 385, and then they say repeat if necessary, adjust coupling critical. Let's have a look down here at what they're talking about. We are talking about the end one. You see that? There's K384, 385, there's L384, there's L385, the inner three adjustments of that end IF transformer. So we're talking about this one over here. Got to be careful because these are the FM and you'd mess it up. So 1, 2, 3. Those are the ones that are going to come into play. Really, all they're telling you to do is to adjust the coupling subcritical so you loosen it. Then you adjust both cores to get the peak on your output meter, and you repeat if necessary, and then you adjust it to critical so that you get the maximum output. Now, this is different in that the previous, or a couple of the other SABAs that I've done, they actually use three IF stages, and they tell you to, after getting this to critical, you reduce it by 20%. So you're flattening it, you're making it more broadband and less sensitive, but because you've got three stages of IF amplification, I guess that all makes up and compensates for that. So we can already tell, for various reasons, that this model is not quite to the standard of the Freiburg or the Meersburg, which were incredibly high standard. The Breisgau that I did in the previous project, or quite a while ago, that had 3 as well. So we do have different standards, different quality levels over here, as you can see. So what I'm going to do now is just get the tone up and see what we're working with. Right, here we go. I've got the signal coming in. I've got 12 dBs of attenuation only, and I can hear the tone. You can see it over there. You can see it on the meter as well. And I'm going to fiddle the volume control. See that? But here's the thing. When I switch on the power supply to give it that minus 4 volts gain stabilization, listen to that. It suddenly cuts out the gain, so I need to give it more amplitude. That's too much. Yeah, I guess I can work with that. See, it's all fuzzy, but I guess that doesn't matter because as long as I can hear the tone, I'm good. Let me go down and show you. I've applied the 4.5 volts to there, so I had to increase the signal amplitude a bit. And we can hear it, and we can see it over on the meter over here as well. See that I've got this on maximum volume? Yeah. I can actually give it a little bit more amplitude, I think. Make it easier to see on the meter. And I'm going to put this on dummy load, and I've got to do this to both because, of course, this is stereo. So, what do we need to do? They tell us to critically uncouple this. So we're going to raise it. That kind of got rid of it, which means I have to increase the amplitude again to even hear it. Let's put it around the middle. I'm changing the amplitude on the signal generator just so I can get a reading on the middle there. And now all I need to do is adjust these guys for a peak. Whoa. It's obviously a peak over there, so I'm going to decrease the amplitude on the signal generator. That's very sensitive there. That's about a peak. Let me try the other one. Whoa, I've got to decrease the amplitude again. Could it have been that far out? It's definitely a peak there. That is so sensitive. That seems to be it. I need to do this again because it really is sensitive. And now I've got to increase this guy till I get a max. And of course, to do that, I need to increase the attenuation. So I've given it another 12 dBs and see, that was too much. Still going. More attenuation. And there it goes down, so that is my max. And of course I'm going to have to do that again, but so far we seem to have peaked that transformer. What do they tell us to do now? Now our attention is drawn to this IF transformer, and they tell us to adjust the coupling subcritical with K8385, 83 and 5, adjust L83 and L85 to max. So exactly the same as we did with the first one. Now which one is 8385? Here it is, K8385. So it's the one here, this IF transformer, this one over here, and 8385 is 1, 2, 3. So it's these guys closest to the tube. So let's get that done. So let's do what they tell us to do. They tell us to critically uncouple, subcritical, so we've got to undo this guy. That should be enough. And now we need to adjust. Now this guy is very low down. I'm going to try this with this. This is in the way. Damn. Okay, I'm going to use my kebab stick, which is longer. Am I doing anything? To see if this fits. Yep, it fits. I think I've got it in there. Let me give it a bit more signal. I'm hearing something here. Let's see if I can peek it. Whoa. Attenuate 6 dB. This thing's going to need redoing a few times because it's extremely sensitive. Yeah, this is not easy. I'm just changing the attenuation on there. See if I can peak this critical now. Increase attenuation. Increase attenuation. There's the peak. Oh, that was not too easy because those guys are incredibly sensitive, too sensitive. I'm going to have to redo this all again, probably a few times to make sure that I've got this thing working right. The last thing they tell us to do is to adjust the IF trap over here. The IF trap is you send a signal to the antenna at 460 kilohertz. You adjust this till you hear nothing or the least tone possible. And the reason for this is that it basically blocks 460 kilohertz from either going in or coming out of the antenna. So let me just do that. I'll just do it like this. This connects to ground. And this connects to the antenna. That should do it. Now, if I feed 460 kilohertz, it's going to have to be a pretty strong signal for me to hear it. But let's get the speaker on. I've got the speaker on, not dummy load. I've got the volume on max. Now I'm going to remove attenuation. I can sort of hear it, but I'm going to increase the amplitude. Yeah, okay. I'm going to leave the tone in there, but we can see it on the meter. And it's this guy over here, adjusted for a minimum. Let me just see something. If I put the dummy antenna on here, there was no antenna, it was just a signal generator, but I'm putting a dummy antenna on there. Somebody obviously fiddled with this guy, because now I can't see anything, and I've got 15 millivolts coming in there with no attenuation. And that's it. That's our AM IF alignment done, according to the instructions. Good. I decided to do a quick check on the actual IF alignment using the visual method by feeding, in the same place, feeding a sweep base centered on 460 kilohertz with a span of 14 kilohertz, so it starts below and it ends above. And I can get the result of that on the scope. That signal you're seeing on the scope there is actually being taken from the, not quite the AGC voltage, but just after the diode, the detector. So we're getting that negative voltage inverted, which is why you get the bell curve. And I was expecting a lot worse. I really was. I was expecting a lot worse. Let me show you this on the scope, more close up. Yep, now we can see it a little bit better on the screen over here. What you're seeing there on the screen is exactly what we're seeing over there. So what we've got is, I've got the center frequency at 460 kilohertz, and it's coming in straight in at 460 kilohertz. There we're getting the trigger. And the actual hump is just slightly to the right of that. This thing's got capacitors in there, so it might be delaying it, because if I change the sweep speed, that actually shifts a little bit. And I don't know that I can or even want to try and get a better bell curve. I can try, but I'm not sure I'll get a better bell curve than that. Let's see if I can. I'm going to try it with this one, which is more accessible. If you remember, that one there was a little bit deeper inside. So let's see what happens if I take the coupling off or reduce the coupling. If I increase the coupling, I can go over. I see, it flattens the top. That would give me more fidelity if I did that. But if I go under, it just becomes smaller, which is not what we want. They want the maximum amplitude, which was there. Okay. Now, this is the bugger that's so sensitive. I may regret doing this, but my curiosity is piqued. Excuse the pun. Okay, I can shift that slightly that way. Whoa, this is the one that just goes crazy. I can do that and then compensate with this one to get it centered. Yeah, you sort of stagger tune them, and you can change the exact center of this. But this one here is incredibly, incredibly sensitive. Use a thinner one here, so that it doesn't. Yeah, you get the picture. I think I'm going to leave it exactly as it was, which is something like that at a peak amplitude. There we go. Now, as I said, this is surprising. I would have expected the bell curve to be a little bit wavy elsewhere, but then again, we're only aligning two IF transformers, so it's not too bad. Okay, that's done. Let's give this a try out. I've done all those alignments, and I want to see just how well this works. And by the way, this thing, I love this thing. This is one of those really, really cheap frequency counters, and you can fit in, you can program in the IF frequency, and then it'll deduct or add whatever amount you've programmed in. At this moment, I've programmed in the 460 kilohertz, and I'm measuring this with a little coil. Let me show you. Literally just this, above or on top of the inductor that sets the medium wave. You just mess around there till you get something, and you will get something. And what I've got here at the moment is reading 1530, well, close. And 1530 is the frequency of our local AM station. And there it is. So this thing is actually fairly accurate. The point is, I want to give this medium wave a try. Don't want to stick to that music for too long. Mini whips in. You can make this react faster or slower.
Fuera 1-1, llegas al área 6-2, el Villarreal solo ha llegado 12 al área rival.
The antenna switch seems to be okay. I missed just touching it with my finger. That magic eye, you can just see it through there. That's working very well. This is afternoon here, which means this thing is receiving very, very well. Let's see if we get anything on long wave. Long wave, I've got to change this to the other coil. I don't know what this is, but it's always there. At 198, in the evenings, I can pick up Radio 4, BBC Radio 4. Other than that, something else here. Other than that, it's a few beacons here and there, depending on the atmospheric conditions. Let's try shortwave. There's something I want to show you here on shortwave. This shortwave, contrary to what I first imagined, is actually just the 49 meter band. It doesn't extend very far. It extends from about 5.8 megahertz to 6.22 or 23. As you can see here, it's at the end of the dial. But I want to try something here.
Including Charlie in the Chocolate Factory and Matilda. Yes, there have been concerns about some of them.
That is 6.195 megahertz. And if I look on the shortwave info site, looking for BBC, and I look for the strongest signal or strongest signals, I get the last one down here at 6.195 megahertz. And that's what I'm picking up. The other one is at 7.265, and I can't reach that because it's off this band. But it's interesting that this thing can be quite accurate. Okay. For this time of the day, this is actually picking up a lot more than I expected. But I find it interesting that you can actually use this quite well. I hope this doesn't catch on, or every tube radio in the world is going to end up with these glaring blue or green lights sticking out of them. I don't like that idea, but I do like the idea of being able to check it just like this without being too intrusive, because all I do now is I just remove it and it's gone. This thing's just been fed by a... Actually, I had this on the wrong coil and it was still picking up. Okay. This is just being fed from the bench power supply, 12 volts DC. And it works very well. I like it. And that, my friends, is where I'm going to leave you today. I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links in the description below. Thanks for watching. Bye for now and stay safe.